And so we wanted to welcome Liang and Edison here. They are both students in the School of Mechatronics Engineering at Simon Fraser University. So Simon Fraser University is a university in Vancouver, BC. And I partner with them as part of their industry advisory board, but they have a fantastic program there for folks who are interested in mechatronics. And they have a lot of support from the school and supporting their robotics team. And so Liang and Edison's team has been competing in Canada and in the US. And so they're here to share more with us today. So with that, I will turn it over to both of you and feel free to share your screen.
Wonderful. Okay, let me see if I could get my screen sharing to work in the first place. I don't think the screen sharing button actually works on my computer for some reason, which is, let me see. It's the third button, right? The third icon on the bottom is the screen share button.
That should be the one.
Yeah, it's not responding on my desktop. Okay, I could try.
Hello, hello. Ah, now my microphone is working.
Yes.
Okay. I could do the presentation for you if you want.
Yeah, I'll just tell you to change the slides.
All right. Give me a second. This one.
Perfect. We can see that.
All right.
Wonderful. Okay, so oh, I could take over. Sure.
Does that work?
Allow this. Oh no. Reset cancel for now. Okay, so I'm here to present the competitive robotics experience. So my name is Liang, first of all. Oh, am I presenting now? Okay. Now it decides to work. Great. Okay, let me quickly. My bad. That's it. My apologies. It is struggling a little bit.
That's fine.
Yeah, my computer is a little old, unfortunately. Not share battery. There we go. Start slideshow. Are you guys able to see presentation? Oh, slowly up for now.
So
it's loading. Yes, we can see it.
Okay,
There
wonderful.
it is.
Okay,
Yep.
Wonderful. Okay, so I'm here to present the competitive robotics experience. So firstly, just some background on me. My name is Liang Nie. I am currently 21 years old. I am a fourth-year mechatronics student doing undergraduate at SFU. I've done 1 year of FRC in 2020. Unfortunately, COVID then hit, so I wasn't able to do FRC after that. And I've also done 2 years at RoboMaster North America. You guys are probably pretty familiar with FRC and FTC, so I'll just quickly give an overview of what is RoboMaster. So RoboMaster North America is an international spinoff of the Chinese RoboMaster competition. So the competition, in essence, features robots on wheels whose purpose is to shoot the enemy robots till the hit points straight to 0. And the overarching goal is to get the most amount of points at the end of the match. It is a hyper gamified version. It's just a hyper gamified match, so we aren't actually destroying each other's robots. There are armor plates on the robots in which we have to specifically hit in order to induce damage. Of course, there's a lot of other limitations, power usage and all the other stuff, but in essence, it is kind of like a video game. So, on to my first experience at first robot competition, which is FRC. So, starting in grade 10, I got dragged into FRC by a couple of my friends because they were doing our FRC year, first year was doing really well. And unfortunately, a lot of our executives graduated that year. So the executive team was pretty bare bones. I worked on the mechanical for that year. So if you look back to 2020, the game that year was Infinite Recharge. There was, to give a quick overview, there were yellow balls in which you had to score into specific sections. There was a color wheel section and there was a climb section. I specifically worked on the color wheel that year, which unfortunately was never used because no real team really got to that stage during the qualification phase. I was also the driver that year. And as a result, we kind of got obliterated, put it simply. Our robots did not function that well that year. And as a result, we did get second last overall. The season was also cut short, so luckily we were still able to participate in the competitions. But a lot of other teams, especially in the States and other places, just never got to compete because COVID started flaring up and the competition started getting canceled. We also did set the second highest amount of penalty points that year, totaling 168, which, fun fact, Edison was on the other team, which is some foreshadowing, I guess, which is pretty interesting. So, what did I get out of that? Mostly trauma from driving, because getting that many amount of penalty points as a first driving for the first time was pretty brutal, but it also gave me a great insight into how rough an engineering competition can be. It is not all fun and games. If your robots aren't doing well, you're gonna there is no mercy per se. Another thing that I also got out of it was a lot of trinkets. So that's kind of where I started to do my own things as well by collecting team pins, which is a FRC tradition. So as for my first experience in a robotics competition, it was wildly overwhelming per se. I had to drive and do scouting and help out where needed. So as a result, I kind of overextended, which wasn't the best decision on my end, as I didn't eat for 8 hours one day, which is honestly self-induced. But it honestly was just, it was my first experience, so I kind of really didn't know what I was jumping into. So I kind of tried to do every single role, and that was kind of a mistake on my end. After that competition, COVID went in full swing. So in grade 11, nothing happened during in the club. All the executives of the 2020 season graduated at that point. So once I was in grade 12, me and a couple of my friends attempted to restart the club, but unfortunately last minute, we decided to cancel our participation because there was still a COVID risk. This was disappointing, but in the end, it also is just the nature of robotics competitions. Sometimes there are things that you just cannot control, let it be a global pandemic or more recently, terrorists in our case. So on to RoboMaster North America. We started in my second year of uni. Edison Wang, who is in this call right now, he pulled me into it. And initially, I got assigned to work on the Sentry. So in RoboMaster, there are 3 robots. There is the Sentry, there is the Infantry, and there's the Hero. The Sentry shoots 17. Okay, let's start with the Infantry. The Infantry is a human-controlled robot that shoots 17 millimeter balls. The Hero is a human-controlled robot that shoots 42 millimeter balls, and the Sentry is a robot that can have dual barrels of 70 millimeter balls, but cannot be human controlled. So it's fully autonomous. So initially, I got assigned to work on the Sentry turret, and I worked on it by myself. Later on, I got sidetracked to work on coding the Infantry, Sentry, and our second Infantry because we were allowed to do that year. It was very busy because we were the first international team to have ever attempted to compete in 3v3 as a first-year team. So as well, we had to build all 3 robots from scratch, and that took a lot of time out of my ability to do schoolwork. And thankfully, I was able to manage it, but it was barely manageable, honestly. A week before the comp, Edison was able to get us access to a whole classroom, which allowed us to finish coding up the basic functionalities of a robot. As you can probably see behind me, I'm currently in the lab. It is a great place to work on the robots, but there isn't a lot of place to straight up test driving the robot and test shooting it and do practice matches. So having a whole empty classroom was very beneficial for us. I was able to also figure out the Sentry's autonomous functionalities during this phase, as I was able to fully test using an entire room. Another benefit of having an entire room is we were able to do practice matches, which is something that is very important now that I've experienced both sides of whether or not we do practice matches and not. Practice matches generally help introduce the driver to the characteristics of the robot, and it is probably one of the most important things. If a robot functions okay, but your driver is really good at using it, is better than a driver that doesn't know how to control a robot, but the robot's pretty good. So we had a lot of overnight sessions in that classroom, so we'd stay till like 2 a.m. for many days in a row just to get these robots done. Another benefit was with this empty classroom, we were able to set up our own competition server such that we could actually test out our interfaces with their server, because it was pretty buggy to say the least. And yes, we had a ladder. There was a ladder in the classroom, so we used it as an obstacle, because in the actual matches there were obstacles in the way. The day of our flight, we decided just to stay overnight at the school and head straight over to the school. I had to go home first to pick up my dad so he could drive me to school, and then he could drive me to YVR, which is Vancouver International Airport, which is where we took off from. Unfortunately, we had major luggage issues in which our robots were too heavy, and this is something that a lot of other teams faced. So a lot of other teams would just ship them through postal. We decided to just ship them, take them as carry-on. So we had a heavy weight restriction. What I tried to do was I tried to classify the robot as a musical instrument, because the weight limit for musical instruments was 80 pounds. Unfortunately, they didn't let me. So we had to take apart the robots, and it was honestly kind of a pain to do that in the airport. We landed approximately at 8 p.m. in Colorado, and we took the bus over to University of Colorado Boulder. So once we settled down in our dorms, we started unpacking everything. We were really tired by then because we haven't slept in a long time, but we were really excited because it was our first time actually competing as a club. And also, that also means we had no expectations as to how well we do, as it was our first time. So we didn't really have anything to fear. We got all our robots in one piece. We all made it in one piece. So there was nothing to be sad about, per se. A lot of teams actually did lose their robots in transit. And that happens every year because some teams, I believe, some teams use postal, some teams like us check them, some teams actually drive their robots. Well, they drive to the competition with their robots in their car, and different methods can cause you to lose your robots in different ways. Thankfully, we didn't lose our robots, which was such a blessing. Because we arrived when the competition started, we had to wake up early to wheel the robots to the competition building. And because we arrived the day of inspection, we unfortunately were not able to do any full checks on the robots. So we had to fix a lot of components, which means we got sent to the box of shame, which is a section of the room in the section of the inspection room in which teams were allowed to work on the robots and fix it. So after all our 3 robots passed, we got to do some practice matches. And thankfully, our robots that year were heavily overbuilt. So they were practically indestructible, which means we didn't have to repair a single part of the robot during the entire competition. This is really rare. Most competitions, at least one part will break. We didn't have a single breakage, which was great for our first year because we kind of just sat around, talked with other teams and stuff. During downtimes after our matches, we first check if the robots were fine, which they were, and then we just derp around. So what I'd do is I'd explore the competition area, talk to teams, get your trinkets because I love trinkets, and then I also race scooters with Jan, a friend of mine. It was kind of expensive, honestly, but it was really worth it. It's a great way to both go explore, because one important note, when you're at a competition that is in a new place, is always really nice to explore the surrounding area, because it's always different than where you're from, generally, if the competition isn't somewhere else. Another thing that Jan and I did is we started helping other teams. Because we had nothing else to do, we helped out NYU with a dbus to your interface, and we helped out UBC with a power buffer logic diagram. So that was another thing that we got to do, which was really fun. It helped us with interacting with other teams more naturally. We also brought an A1 Mini to the competition, which means that we were able to print components for other teams, which a lot of teams needed printing because a lot of teams parts broke. Colorado University of Colorado also provided some really good food. So we have no complaints. I have no complaints of that. During the competition, I yelled a lot, so I lost my voice after the first day. And we did a lot better than we expected, especially as a first-year team doing 3v3, which was unheard of in RoboMaster North America. Having our Century autonomously take out robots was extremely liberating, and personally, one of the highlights of the entire competition for me, as I coded that. We barely didn't make it to the final stages, as it was the top 8 teams. We got 9th in both sections, which, as sad as it is, we're pretty happy with that result. Because we didn't make it to the finals, we were able to go out and have a celebratory dinner. So we went to the steakhouse, and I ordered. Actually, kind of forgot what that was. It was really good though. We also were able to explore the campus and the surrounding towns, and unfortunately, I was not able to find the Boulder, which gives Boulder, Colorado its name. But exploring the campus and admiring the scenes around was honestly really fun. So next day, after the comp, we packed up everything and we went back to BC. So overall, it was a great experience. First experience of RoboMaster North America. We had little to no faults, which means we got a ton of time to go and explore both the campus and the city around. The food was pretty good too, and we had a blast. And personally, the biggest note I have for this is I redeemed the FRC match that I did back in 2020, as we did a lot better than we did in 2020. It's kind of a petty thing, I guess you could say, but having done well in the competition after doing horribly in a previous one is a great feeling, and it boosted my confidence a lot in designing and working on the robots. So, onto the most recent competition, which is RoboMaster North America in 2025. So, unfortunately, this year I had an 8-month co-op from September to April, so I wasn't able to contribute a lot in the design process. Though, as a result, I got put as the lead for a hero robot this year. Before co-op, of course, I decided to experiment with designing an indexer for the hero. I also really wanted to help out with the club more, but I didn't expect co-op to be so taxing on my ability to do things on the side. I still came in after work on Wednesdays to teach new members So I taught new members how to do SolidWorks, and more specifically how to start coding embedded, because all our robots are coded on the STM32 platform using C, using STM32 Cube IDE. In hindsight, I could have taught that better, but hindsight's 2020, and I'm working on improving that now. I also helped in other aspects as much as I can. So I helped Edison with adjusting his CNC, and I also played around with the Hero ball path whenever I had time at my co-op. Unfortunately, progress this year was slower by approximately 2 weeks. And as my co-op ended, I began working on finishing up the mechanical and electrical components that everyone else was working on, so code could be written. So the reason why everything took so much longer is because the 2024 to 2025 year was meant to be the year of experimentation. So we tried a bunch of unique, fun ideas. Most of it, unfortunately, didn't work the way we wanted to. For instance, one thing we tried was a pneumatic boost, which was a pneumatic reservoir that connected to each wheel, such that when the driver pressed a button, it would boost the RPM of the motor of the wheels, causing it to dash in a direction. Unfortunately, it wasn't allowed in the rules. We also tried a modular chassis design in which you could take apart sections of a robot if a part were to break and swap it out. We didn't modularize the wires, so wire management was abysmal. That also did not work out. Though some things did succeed. So firstly, the swerve drive did succeed. We decided to try swerve this year. So two of our 3 robots had swerve, the infantry and the sentry. Both worked just fine. Unfortunately, designs started to fail later on during the competition, but I'll get to that later. And the most successful thing that we tried was the quick turret disconnect, which allowed us to quickly connect and disconnect the turret. I can actually demonstrate that right here. The quick disconnect turret allows us to take the turret and allows us to pack these things separately during transport, and it also allows us to swap turrets, which can be fun at times. But mostly it was for ease of transportation, and this helped us a lot, and it was really cool to show off. Let's put that there. Make sure it doesn't fall. Good. Because all our robots were already behind the schedules and the designs were all new and funky, assembly took too long. We first finished off the infantry robot. So with that, I was able to code up a temporary swerve code just to get it to function and drive, and then design a power buffer around it such that the robot is functional enough such that we could stress test it. The Sentry chassis itself was finished next such that I could port the code over and then tune that and set the encoder values such that all the wheels are facing the right direction. Hero, even though Hero I'm technically the lead of Hero. After the assembly was done, my friend Jan took over the code for that, as he is the coder for the Hero itself. So my contributions for that robot ended after the assembly and electrical connections are done. Similar to the 2024 season, the last week or two, we did multiple overnight work sessions. Unfortunately, this year we did not have access to that classroom, so we had to work in the lab. This means that we really didn't have a large space to test. We were still able to test shooting and driving, but we weren't able to have full-blown driving practice tests, which is fair. We weren't really in the state to actually test the robots anyways, because our robots weren't fully assembled at all anyways. This means we also really couldn't test our server stuff. Thankfully, Jan was able to code up a interface for the server through code beforehand, such that we could just plug and play it. And thankfully, it worked really well. We also had a lot of good food runs. Every night, we would go to the store restaurant called Kokoro, and we would go and eat food before heading back to the lab at times to continue working on the robots. That, even though it was kind of expensive in hindsight, it was a great boost to morale, and it helped out with us to continue working on the robots. This year, because of the disappointing progress with the robots, some of us decided to leave for San Diego 3 days early. So Jan, Edison, and I left 3 days early, and we booked a hotel such that we could work on our robots in there. Compared to 2024, I'd say our robots were arguably less effective, and our code was both less stable and reliable before we left for San Diego. To give you some context, our robot Sentry's turret wasn't even done assembling yet when we left. It was still in some capacity disassembled, which is honestly very disappointing, but that's also why we left 3 days early. After arriving, we started by crashing and falling asleep. Because we decided to do the same strat we did last year, which is staying up overnight. We had not slept for 27 hours, and so as a result, we unpacked in the hotel, ate quite possibly the best tacos ever, and then we slept for 17 hours. Personally, it was great and really needed. Afterwards, we finished up the assembly of the robot, and such that we could start coding and tuning the robots. Unfortunately, with the design of the robots this year, tuning the robots was exponentially harder, as we both had dead zone issues and mass issues in which our motors weren't giving enough torque. Just made tuning harder with less amount of time. So as a result, our robots went into the competition kind of in the progress of tuning still, which isn't actually much different from a lot of other teams. This was all done in the hotel, as school dorms weren't open yet, but it was a cool hotel. I've never really seen a hotel like that before, so it was, I enjoyed it. One day before the comp, we were able to check into our rooms. So as a result, we called Ubers from the hotel to the dorms, and a couple other people were arriving the same day, so they just took Ubers from the airport to the dorms, right? It wasn't really coordinated, but it worked out in the end. In hindsight, we probably should have coordinated a little bit better, but in the end, we were all arriving at the same destination, and we all had the same end goal in mind, which is getting there safe and sound. Because we were able to get the robots pre-assembled and prepped, we were ahead of many teams who arrived a day before the comp. This also means we were able to breeze straight through pre-inspection because our robots were already up to code. So all we had to do was bring it there, get the inspection sticker put on our robots, and then we were done. A lot of teams who arrived during the pre-inspection, some of their robots didn't arrive on time, and as a result, they weren't able to even do pre-inspection till the day of the competition, which thankfully we were able to avoid by just arriving 3 days early, which was really fun, honestly. Finishing these things early means we could settle down, which was great. The food court unfortunately wasn't that good. Talking with the UCSD members, they did mention that the food court we went to was one of the bad ones. There were better ones, but we just didn't get access to it, unfortunately. UCSD also had scooters, which also drained so much of my hard-earned money from co-op, but I would absolutely do it again because it was such a fun time racing through the campus to see who can arrive at destinations faster. Unlike last year, though, our designs this year were so much more delicate and rushed, which meant we had to actually do repairs. Now, which is kind of expected, but the amount we did was pretty shocking. So, repairs first of all, I want to say repairs during the competition is expected. It is actually more the norm. Things are going to break, especially due to things that you did not think of. In our case, we had issues with our swerve, we actually had a lot of issues with our swerve. We had balls jamming the swerve drive. We had fiberglass shredding due to vibration, and as a result, we had to salvage parts from the Sentry. This also does mean we had no downtime during matches, so I wasn't able to go help other teams or like talk with them as much. We also had major code issues as well because of how little time we had to code. For instance, hero power buffer, which limits the amount of power the drive system could get so it doesn't kill itself in the match. It never worked for some reason, and I was never able to have the time to debug it because the Sentry code, we just never had time to fully code it. Another problem, I guess, is the Sentry caught fire at 3 a.m. and well, I was trying to code it, so I kind of turned off the robot, told Edison that the Sentry caught fire, and went to sleep. I was so done with it, so Sentry just stopped working after that. We hard coded it to aim at a specific corridor and just mag dump. Despite all these issues and the fact that our first year robots were honestly just better, we somehow qualified for the finals in both 3v3 and 1v1. So in the end, we came in 6th in 3v3 and 4th in 1v1, which is absolutely insane. We kind of expected to actually do worse because of how well we did in first year. So as you can probably expect, we were really happy. Unfortunately, I feel like we could have gotten 3rd or 2nd in 1v1 if the Sentry swerve didn't jam, but that's nitpicking. And honestly, getting 4th in 1v1 is already amazing. I have no complaints. After losing in both 1v1 and 3v3 to VT and I think UW, me and Jan and a couple other people were able to make rounds, talk with other teams, and of course get trinkets because I love them. I love to collect them as a memorabilia of the competitions. So because we made it to the finals, we didn't really have a spare day to just explore the campus and have fun like we did in 2024. I still made some time to wander around and explore both the bookstore and other sections of the campus. I had an opportunity to talk with many other people from many teams because of both my position as a coder for the team and because I just wanted to talk to other people. I met with a lot of amazing people that year, and I learned a lot about their design choice and stuff, which is something that I'm totally gonna leech and use this year because they've experimented and they told me about it. I might as well use it. I'm planning to use it for the 2026 season of RoboMaster, which is technically ARC now, but that is a whole side thing that doesn't really affect anything. Unlike 2024, I decided to be a little bit more proactive than I already was, and I decided to help out the organizers by packing up and cleaning up both the arena and all the miscellaneous stuff. As a result, I got to meet a bunch more cool people, especially the volunteers, whose hard work helped run the competition. And I got to talk with a lot of them and share insight as to what their thoughts were, and it was a wonderful experience as well. I also was given permission to take a bunch of posters from the competition as they didn't really need it anymore. So in our lab now, we just have a bunch of 2025 RoboMaster competition posters. And as well, I also got to explore the campus, which is very different from the SFU Surrey campus. So next day, of course, we packed up and headed for our flights back home. Overall, it was a great experience once again. In terms of technicality and like just the experience of the competition, it was completely opposite compared to the 2024 competition, in which we had to repair nothing. Nevertheless, it was still a blast, and I got to meet up with a bunch of people I met in 2024 and catch up with them. Like, for instance, the NYU guy we helped out in 2024. I absolutely would do it again, which is why I'm still here. Now, some tips as to what I would recommend when you're going to a competition, especially if it's your if it is your first time. So my first tip is to be proactive. Try to find things to help your team. So see if they need parts to be repaired. See if they need scouting to be done. See if they need pictures to be taken. It is a great learning experience, and it can help you get immersed into the competition experience and overall improve your experience of the competition overall. Another tip I would have is interact with other people, especially other people in different clubs, in different teams. Of course, if they're busy, let them be busy, let them work on their things. But if they're not busy, it doesn't really hurt to interact with them. They're all here to compete, and they all have their own stories. And learning from their stories is personally one of the key points of the competition. Because in the end, the robotics competition, versus RoboMaster and also FRC and FTC, they're a competitive competition, but they're also a networking event. So you might as well talk with people and get to know them and learn from them. And final tip, final tip would be to have fun. It is very cliche, but do things that you find enjoyable. For instance, one thing I find enjoyable is to both take a lot of photos of people and get trinkets, as the 95% of the photos in these slides were taken by me. Pretty much, the goal of a competition is to both learn, but also to have fun. So make sure to not forget the have fun part. And that should be it.
That's amazing, Lang. Thank you so much for sharing your journey and experience. I'm curious, how many teams compete in RoboMaster each year?
I think approximately 24. There's a lot more people that participate in 1v1 than 3v3. So just a quick recap, I guess. 1v1 is one robot versus one robot. 3v3 is three robots versus three robots. I think around 26 to 30 teams participate in 1v1, and then around 20 to 26 teams participate in 3v3. And there is an overlap between the two as we participate in both.
Perfect. Thanks. Akash, you have a question?
What do you think is the biggest difference between FRC and this?
FRC and RoboMaster, or FRC and FTC?
RoboMaster.
Okay, the biggest difference is the end goal. The end goal for FRC is to do a set task. So you have, for instance, my best recollection is the 2020 Infinite Recharge, in which you had to shoot balls into specific hoops, and then you have to climb at the very end, and then that determines the amount of points you have. And RoboMaster is a lot less spelled out, I guess you could say, in which you're given an arena, you're giving a set of rules that your robots have to comply to, but the strategies that you use and the design you decide to choose to follow is your own choice. And as a result, there's a lot of very unique robots that participate in the competitions. For instance, there was one robot whose turret was like a foot above their robot, such that they could look over their own robots and snipe from the back of the arena, which was a really cool strategy. And yeah, so I feel like the main difference is it allows more freedom in choosing how you tackle a problem.
Okay, great. That answers my question.
Yep.
Hey, is RoboMasters a pure competition, or does it have judging like other first events?
Can you repeat the question?
So you know how in FTC and FRC there's judging where you have to go
Oh,
showcase the different parts of your robot. Does RoboMaster have something like that, or is it just a competition?
Um, the Chinese version of RoboMaster in 7v7 does have that, and it affects the match in some way. But in our case, in RMNA, RoboMaster North America, in 3v3, is just point based. The end result of the matches are determined by the points you score during the match. So not fully like that. Oh, Edison? Yeah. Uh-oh.
Yeah, to expand a little bit on that, the Chinese version, you are required. So the 7 category in the Chinese version, you have to have a extended document on your engineering decisions, and like every single point of your robot has to be well documented, and then they like that document is graded from a rank D to rank S, and that affects how much starting economy that you have from the start of the game. Economy allows us to purchase projectiles during the game, and so like if you get like something like a grade C or something, you get like a 50-point penalty at the game. So it makes your games worse and harder to play, but it does not qualify you for it's not like a major judging point. There are technical awards that are geared towards open sourcing and some documentation. But the competition, unlike in first, where there's a lot of focus on the documentation, like for FTC, they have the Inspire Award, which is like a large chunk of it is documentation and outreach. In RoboMaster, the larger chunk is now the competition itself versus the pure documentation.
Thank you.
So it sounds like in 2024, it was kind of fast and furious, fail fast, learn fast, iterate, and you found great success in that. And then year two, you had a lot more knowledge and experience to think through strategy and design. So if you could do it again, or if you had advice for this team, where do you think they should spend most of their time in just trying a design, failing, learning, and iterating, or in the strategy?
It never hurts to generally try to iterate, but there are some key aspects which have been proven time and time again, like design mechanisms and stuff. For instance, I guess the main point I'm trying to push here is don't reinvent the wheel. If something has already been invented and it works really well, there is no shame in looking at how they do it, taking reference to it, and redesigning it such that it works in your case. Of course, I would recommend against just copy pasting, because if you just copy paste the part directly into your robot, you don't learn from it, and even though it may work, but you don't really get the knowledge of why that part works and stuff like that. So I would recommend to work on not only your own designs, but also seeing how other teams do their designs and seeing why their designs work and if your design can be improved as such.
Perfect. Thank you so much. Any other questions from the team? Oh, Akash, you have one?
Yeah, I was wondering, what kind of language do you use to code your robots?
So we code in C, and we use the STM32 microchip.
Okay, thanks.
And lastly, are you going to compete again next year? Or are you going to go to FRC maybe?
We are going, I don't think I can compete in FRC anymore, as I am a fourth-year university graduate, undergrad. But I am absolutely planning to continue to work and compete in RoboMaster which is why I'm actually in the lab. After this session, I was planning to continue to work on my components, but there are so many new things that I want to try out and improve on my previous iterations, and it is too much of a shame to just stop now. So yes, I do plan on continuing to participate in RoboMaster with Edison, of course.
Fantastic. Well, we're looking forward to hearing more about your journey, and we wish you great luck and success.
Thank you. And I wish you good success with your competition as well.
Thank you so much. Like you said, it's a journey, and there's so much to learn along the way. It's all about the journey and the experience. So I appreciate it, and it's definitely an awesome community with all of the robotics folks that are interested in this space. So thank you so much for sharing your experience, for your time. It looks like there's no other questions, but we will connect back with you, let you know how we're doing, and I will see what I can do about sending you some Boeing trinkets as well to add to your collection.
Well, oh, yes, please. That would be greatly appreciated on my end. Yes.
Absolutely. Well, thank you both for your time. Thanks everybody from Sounderbots for joining. Hope everybody has a great evening.